Okay, welcome to the second lecture for verifying trig identities. Okay, so to verify a trig identity means to make one side look like the other. So one of my favorite strategies is to pick on the biggest side. So I like to pick on the bigger side here and then try to make it look like the simpler side. So if I can make this yellow side, this left side, look like the right side, then I've verified the identity. One of my favorite strategies to use is to turn everything into sines and cosines. Usually that helps you see what you should do. So we're going to use that strategy on this first problem here. So secant of x is the same as saying secant of theta. So we're going to come over here and represent secant of theta as this trig identity instead, and as this reciprocal identity instead. So instead of saying secant of x, I'm going to represent that as 1 over cosine of theta. Okay, and then I'm going to go to tangent here, and I'm going to turn tangent into sines and cosines. So to do that, I'm going to have to go down here to the quotient identities, and I can see that the tangent of theta is the same as sine of theta over cosine of theta. So I can come over here and represent that tangent of theta as this instead. And then from there, don't forget that we still have that sine hanging out up there. So we're going to have to do some fraction math. So we're going to move that sine over here. So what we got is we've got, sorry, technology. Okay, so we've got this. Remember that this is multiplication between the tangent and the sine. Okay, so what we have here is 1 over cosine of theta minus sine over cosine times sine. But remember, that could be represented as like sine over 1. And also, all we're messing with here is the left side of the equation. So I like to keep track of where I'm at by putting the equation or the equal sign on the right. But I also like to save time and not continue to write this right side over and over again. We know that we're trying to make this left side look like the right side, okay? So what we have here is some fraction math. So we can multiply these fractions, and then we have a common denominator of cosine. So we have we can multiply the numerators on this side and then combine these fractions. So if we do that, on the top of this first fraction, we're going to get this. We're going to get, so 1 minus sine squared of theta. So the denominator, we're going to get a common denominator here of cosine of theta. So let's just pull that over here. Okay, so there's our denominator of cosine of theta. And then, so this is what we're still equal to. So you can see we're getting closer. Remember, we always keep that right side in mind. What are we trying to make, okay? So what we do like is we see that cosine's on the bottom here, and we know that that secant is cosine's reciprocal function. So that could be interesting. But the big clue here is this 1 minus sine squared of theta. Now this 1 minus sine squared of theta, we've seen before. It's down here. It's the main Pythagorean identity. So we can represent that as this cosine squared of theta instead. Okay, so we can say cosine squared of theta. Get that over here. So now the top, the numerator, instead of representing it as 1 minus sine squared of theta, let's call it cosine squared of theta. And then so what that does for us is it helps us eliminate our denominator, right? So what we have is we've got our denominator of cosine of theta down here. Well, cosines can divide out, right? So what we're going to have this equal to is just straight up cosine. And we know that cosine is 1 over secant of theta. So our last step here is to turn cosine, which is what this fraction would represent over here, right here. This fraction right here would be would end up being cosine. So there it is. Cosine is this other side.